Hello, everybody. This is Charles Anderson, and I'm just a guy from Goodwell, Oklahoma. I've got a really great video game idea, and this is a Java tutorial for JMonkey Engine. This is part 2, Variables in Java. Last up, we did our little Hello World program, and we are continuing on. If you want to email me, it's relic724@gmail.com, and on with the show. Okay, now, in programming, there's variables, things that you can change in your program. Now, there are two official types of four kinds of variables. Now, the first type is called the primitive type. This would be the stuff that we worked with, int, char or character, int for integer, double, it's a floating point notation of a big size, and then there's the float. There's short, byte, I'll get more into that. But these are the ones that, hey, they exist. They're in the stack right there. Boom. Reference types. Now, this isn't a value in and of itself. It's like a reference, like an address, like a pointer to where the value actually is. And can be arrays, classes. Now notice string and int. Wait, isn't int over here? Well, yeah, but there's also a way to refer to values. So, now, these are the two official types. Primitives, which are actual values, and references, which are not the values, but they're like a way to get to them. So, there you go. Now, this third type and the fourth type, I'm not going to go into detail on them at this time. When you start going with this, you're going to get a lot of bugs if you're not extremely careful. So, guess what? This is for the intermediate. I'm not going to go over it. I will go over it right now because the type variable, if you look at Java code, you'll sometimes see a singular capital letter, and usually you'll see some braces around them like this, the less than or greater than sign, but they're being used like brackets or parentheses or you know the square brackets. And so avoid working with this until you get a little bit more stuff under your belt. You have been warned. Raw variables or raw data types, also known as I forgot what I was, and this is usually a result of messing up in here. Because this is where you're saying, oh yeah, there's going to be something here. I don't know what it'll be, but yeah, I'll figure out what it is later. And raw is what happens when it's not quite handled rightly. See, errors. Also, this raw data type is, it is stuff like a primitive. It just forgot what type it was. So, there we go. Type erasure in here. I've said my say. Now, I'm going to, at this time, instanced references are objects, okay? There is a reference in here called object. It's known as a superclass. Again, not going to go over it that much in time. Just make a note of when you see the word object, yeah, definitely going to want to, just heads up, okay? Alright, now, the primitive types. Let's go into that into more detail. First primitive type that we have, basis of Boolean math, Boolean variables. It's either true or it's false. It's either on or it's off. And if you don't specify any variables, any value for it, it's going to be false. Alright, a byte. This is the first of our integral, or it's an integral type, like C integer, but integral in that, there aren't any decimal points or anything like that. Integral. Boolean can be considered an integral type too. There is no decimal on a Boolean. So we've got -128. That's the lowest you can go. To 127. That's the highest you can go. It'll default to 0. Then there's next size up is a short. It's negative this to positive that. Defaults to 0. Int. This is the standard one that's used for a lot of Java, and it goes from negative 2,147,483,648 to this side, which is that number minus 1. It defaults to 0. Then we have long, which I'm not even going to attempt to try to classify this number. It's really big, and only the negative side fits in. But on the other, positive, that, but instead of an 8, it has a 7. So there you go. And 0. Now, car, or character. This is like the letter A, or B, or, just any key on your keyboard, and then a whole bunch of others. Now, it's notated as, it goes from Unicode 000, this is hex, right, hexadecimal, I'll go into that more into detail later, to hexadecimal that. I'll go into that later. But to give it the equivalent, it would be this size right here, int. So, yeah, big. Wait, no, this size? This size. I think it's this size. No, it's this size. Wait, let's see. FF255. Oh, no, this size right here. Okay, so it's the size of short. So, well, I'll go into short sizes later. But anyway, its default character is the Unicode character 0 or null character. If you do not set it. Then we got float and double, and these are the ones that actually have decimal points in it. It's 32 bits in size, 64 bits in size, 0.0f for float, 0.0d for double, 32, 64. And here, alright, I'll show you. Here we go. I have the official Java language specification here. I have it set up. 24 bits for the actual number, 8 bits are used for the exponential notation of plus or minus, and 127, 126, there's another thing in there, which when it reaches that thing, it goes to positive infinity, negative infinity, positive 0 and negative 0, but let's just keep going and say positive 0.0f and positive 0.0d naturally. Alright, so that clunky stuff is out of the way. Now, data sizes. This is just throwing it in there. Java is a bite-sized big Endian program. So for those who know, they know. Big Endian means that as you read these numbers, that's how it's stored. So like when you go in there, it's 255. That's how it's written in there. So that's all that big Endian means for us. Bite-sized, byte is what it's based on. Whoop! Oh, did I? Yeah, there we go. All right. So it's all based on bytes. So, but let's go through the sizes anyway. A bit is a bit. It's the smallest unit in computing. This has to do with the Boolean. However, a Boolean in Java is actually a byte. Go figure. But anyway, its notation. This is actually legal to say in Java. And hey, why not? I'll go ahead and pull this up, and we'll start playing with this stuff right here, shall we? All right. Let's can't alt tab. Got to. There we are. So let's pull up our JMonkey engine. Yeah, let's go have some fun for a while. That's starting to sprain my brain. Okay, so let's get rid of all this here. Let's work with numbers today. Let's start with a Boolean, since that was the first one on the list. Boolean. My bool. There we are, and we'll set it to true. Because it'll be false otherwise. And let's go ahead and system.out.println my bool. There we go. And let's run it. Bada-boop. Oh, there it is. It's true, all right. Now, remember when I said the default value is false? So if I don't set it, oh, compiled with errors. Okay, run anyway. Yep. Oh. It won't let me. Might not have been initialized. It is initialized to 0, but okay, so this compiler will not run without a value set. So notice that some compilers will actually run. Its default value is false. But anyway, we can set it to false manually. That way the compiler knows, hey, you didn't set it, dude. That's not good. So yes, we will go ahead and do that. And of course, if I run it, boom, there's false. Great, groovy. All right, what was the next one up on the list? Yes, the byte. 128 to 127. So let's just add to it. Why not? All right, byte, my byte, and that equals. Now remember, we can't go outside of that range, so we can either, we can do like. Let's go right to the edge. Right to the edge. And then dot out. Dot print line. My byte. There we go. There we are, 127. Now, remember that range thing? I'll go on ahead and show you what happens right quick. My byte equals my byte plus 1. This is going to hurt. Wait, why is it? Possible loss of precision. Yes, indeed. Well, you know what? We're going to say, go on ahead, give me my loss of precision. Cast it as a byte. All right. So, here we go. This is going to fail. When it does the red squiggly braces, it's not going to compile, but because I'm doing an explicit cast, I'll go into more on that later. Here we go. Let's see what happens. Oh, negative 128. How? What? Oh, yes. What happens is I purposely caused overflow. This is what happens when you put in a number too big for the number that you're setting. This has to do with those sizes. So, as I add more and more, it starts heading back upwards off of the negative side. So, there you are. And yeah, it's pretty cool to see it when it goes. And yeah, let's go ahead and get rid of that because this is bad code. I'm actually showing you bad stuff there. So don't do what I just did. Make sure to get a big enough number. That's why most people go with integers. Our next number up is a short. And my short. And a short can hold a bigger number. So let's go assign it. Ooh, 13,000. 1,300. Wait, yeah, I can do 13,000. That should work. 13,000. Oh, and you know what else? We can actually goof off a little bit, too, while we're doing this. Watch this, watch it. I can do that, or... Oh, yes. Hexadecimal. This is also valid. 0xf. This is base 16 right here. And, yeah, let's just show you what it looks like. So it's FF. And we'll go system.out.println. And my... Oh, right. It goes outside of there. Okay. My short. All right. And 255. Wow. This is base 16, so this is 15 and 15. So it's 15 times 15? Wait, no. 15 and then 15 times 16. So we've got 15 plus 15 times 16. Go figure. It has to do with the... well, you know what? Why not on the next one we just do a little binary joke? See, next one up is int. All right. And int. This is the standard number right here. This is the beauty. My int. Edger. All right. Oh, okay. And let's put in 10. There we go. And just to make the joke complete. Oh yes. Oh, print line. Get it right. There are, and then, oh, right, gotta concatenate my integer types. Oh, right, gotta put in a space, otherwise it won't put in a space. Of people. Print line. Oop, oh, there it is. Those who get it and those who don't. Alright, there we go. And of course the hilarious part about this is when I run it. Yes, binary. Welcome to binary. There are two types of people, those who get it and those who don't. All right, next one up. Okay, I had fun with that. So that's binary notation. That's hexadecimal notation. There's other notations, and I think we got a couple more left. Oh, car. Wait, I've still got long. Which one do I want to do? I guess I'll change this one right here. All right, octal. This one, this one isn't used much, mainly because it has to do with a nibble size. I'll go into sizes more. Wait, I did go into nibbles, didn't I? Yes. Anyway, 7. So 7 times 8 plus 7. 7 times 8 is 56. Plus 7 should be 63. Okay. So now this byte is going to be 63. Let's go ahead and run that. Yep, 63. There we are. How do I know that? It goes 0, like binary goes 0 to 1. It's base 2. So base 8 would be 0 to 7. Base 10 is 0 to 9. Base 16, or hexadecimal, is 0 to F, where it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And then, there we go. All right, so final one. And to show you the final, what cool thing is, oh, right, it was long. And because long allows us to do stuff, let's put in a seriously long number. And watch this. I'm going to go, let's see, let's go into the billions. Okay, so 23 billion, 485 million, 620, 34, okay, 34,000, 74. All right, there we go. Now, notice what I did. What? Oh, I can't go to, it's a long, isn't it? Integer. Fine. Long. Nope. That's not allowed. Okay, well, let's make it shorter then. It's a long, and yet it can only hold an integer. That says something to me. It's not something great, but it says something to me. So, well, we'll go with this. Interesting. So this compiler can only handle integer size. That is cool. All right, anyway, let's go ahead and print it out. Yep. Dot print line. And big, oh, right. Big number. Oh, yeah. It's a big number. And my So, yeah, longs are actually bigger than you can put in, but because it's the biggest one, you can add a lot of numbers. Now notice these underscores here. It didn't give me an error because you can use underscores anywhere in any number to split it up visually for you, the programmer, and, not lose your place. So, when we place, of course, it's going to put it all together. Bam, there's your big number. But yeah, when you need to make sure to keep your place in a number, you can put an underscore in there anywhere. You can even put just oh well. Control Z, Control Z. There we are. So yeah, I mean you can put underscores anywhere. It's not counted. It'll put it all together for you. So that's one of the neat little things. If you tend to lose your place on big numbers, hey, don't worry. You can put these little underscores in there. It will not lose its place. All right, next up, we got float. And my float. And let's put that out at 53.07 something something float. And there we go. Go print that out. Print line. Oh, no. Let's just print it out. My float. So that way when you need to work with decimals and stuff, you can... There we are, 53.043. Now, the bigger size one of that is if you really need some precision. And I'm talking about like some crazy, crazy awesome precision. 64-bit precision to be precise is definitely used in 64-bit computing. Let's go it's random blah 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 blah. Sounds good. All right, and system out. Hit the period. Out. Print line. Print line. My double. And there we go. And give that a print. Blarp. There it is. And of course it has to do with how big this number can be in length and to what precision its exponent point can go to. Like if I were to say e negative 58 f d. All right, this is valid numbers. It means 27 to the negative 58 d power, which means that it's a really, really small number. Yeah. Oh, and look at this. It's 27 point to the 58, but then when it prints it, it goes 2.7 e to the negative 57th power, which means it'll move the decimal over to the right behind the largest significant digit, and then do its exponent. So there you go. Right, that was cool to find out. Character, my character, Ector. Why is it a character instead of a letter? Go figure. All right. A. Now, you'll remember the string, and we did double quotes, and characters are signified by single quotes. So when working with strings, double quotes, characters, single quotes, and let's print it out. Out dot print line. My character. All right, hit that one. Boop-a-doop. Yep, there it is. That's the letter A, all right. And you know what? We can also do Unicode escapes. What's a good one? This is in hexadecimal, so it'll be like this format right here, where it's 0 through F. Let's see. I know it's 127, so oh, let's go for character 32. Okay, 32 divided by 16 is what, 2? And then let's go up like 4 more. All right, there we go. 0024. So this is actually 36 in decimal. So there we go. And press play. Oh, we got a dollar sign. Ooh, I struck gold on that one. Ooh, imagine that. Okay. Also, you can't do single quotes or double quotes. This is escape character right here. So this is all one character, even though it's in the single quotes. Go figure. Let me go ahead and show you this whole escape thing. There's a list of these escape characters. It's in this Java language specifications. Be careful not to stare at it too much. You will go blind and or cross-eyed, and your brain will hurt. A lot of other stuff. Here we are, escape sequences. So look, line feed, horizontal tab, all this good stuff. But yeah, double quotes, single quotes, and backslashes. And then that octal escape. Huh, why is it an octal escape? Okay. Anyway, so we can go like, hey, I want some double brackets there, or double quotes. Yep, there they are, double quotes. We can even put in the backslash. You got to do 2 backslashes to get one. It's kind of like a 2-for-1 deal. Yeah. All right, so there you go. Escape characters. Yeah, new line. This one's gonna be great. Press the button. Oh my goodness, there's nothing there. Oh, and there's another nothing there. Build successful. Oh yes, new line. So yeah, when print, you can do like print using this character, and it'll still do like an enter. Yep, see, there it goes. So anyway, I'll just switch that back. All right, so characters. Now, why did I not cover string? I used strings in Mac. That's actually a reference class, but let's go back then. So here, around in this area, remember when I added one some time ago, and then it went all negative and weird and stuff? That's because I did an illegal typecast on an overflow operation, blah, blah, blah. It's going to make a headache. But make sure to choose the right size number for what you're wanting to deal with. Okay? Very important. You'll get some bugs if you don't, and the compiler will catch you. And if you do what I do, yeah, you can purposely fully make it go wrong. I made it purposely go wrong. So don't do what I did. Program's got to go right. That's all to do with design. So data sizes, all right? Yes, that's right. So this corresponds to these number sizes. So we've got Java is byte-sized. So the smallest that it actually has is a byte. Everything's at least a byte. So Boolean, it could be represented by a bit, but you know what? It's a byte. All right? A byte is a byte. So Nibble, it gave rise to octal back in the day, back in the 80s and 70s. So yeah, this thing, yeah, base 7 or base 8, excuse me, go figure. Yeah, not really that popular. But base 16 or hexadecimal, definitely popular. Binary, always popular, especially on enumerate. I'll shush up right there. Anyway, so byte. There we go. 8 bits make a byte. 16 bits make a word. And, you know, maximum value in decimal is 255 for a byte. Maximum value unsigned, this is unsigned as well, is 65,535. And guess what? This is that 65,500. I would seriously hate to be the guy who makes fonts. You know, the artwork for fonts. Imagine trying to make all these, drawing out. All right, woo! I've been slaving away for 3 weeks, got 500 characters done, only 65,035 to go. Oh God, why? Why did I choose font making? So all right, so double word 32-bit, quad word 64-bit, and you know this is where our you know processors are headed at, and you know our 64-bit computing. Heck yeah, heck Xbox One. PlayStation 4, the Steam Steambox. Oh yeah, we're gonna be writing games for that, definitely. All right, float double 32, 64, double word, quad word. That's the size that it takes up in the memory. And then finally we have this 128-bit thing out here. It hasn't been named yet. It's used for unique user ID. It's just not even worried about that right now. It's definitely a mouthful because you saw what happened when I came over here. I couldn't even fit a long in there. Sheesh, that's a big number. So I'm guessing a long is probably a double word. Wait, was it? No, looks like int's a double word. Okay, so int's a double word. So this is a quad word. So it's the size of a double. Yeesh, that's one big number. All right, that, and we got to play around with that a little bit. You got to see. This is how big it can go before it starts overflowing, which is that weird, negative 128 negative stuff, and stuff starts messing up. Now, reference types. All right, we got done with the primitive types. Had a little fun with that. Yay, primitive types. Yay. Now, reference types. A reference type is an address or a pointer. In other words, it's not the value itself. It's just points over there. That's what that is over there. Examples of this are a class, an array, a method, interface, label, object. The instance. Remember, instanced reference is an object. So let's go ahead and play around with that a little bit. All right. So yeah, we got this class. This right here. Yep. Yeah. I got static void and stuff like that. Let's go with a string. Yeah, let's go with a string. My string equals new string and hello there. Yeah. Wow. Here we go. And then system.out.println. Println my string. There we go. And we play it. Boop. Hello there. So now one thing. Why did I just go string as a special case? So you can do it like that, or you can do it like that. The proper way is to do it like this. But string has special dispensation with the compiler. Mainly because there we go. Mainly because it's a reference. In other words, these are actual characters in a row, primitive types, and they go from here and they end here, and the first address to the first one is set to here, and then it just goes through each one of them individually and pumps them out there. Now, a string is not an array of characters. It's different. It's got special dispensations. But anyway, let's see. Reference to primitives. Okay, it is an array. So let's go ahead and mess with arrays. I'll do classes later, methods, interface, labels, all this stuff later. Yeah, I'm going to save your brain, and we're going to have fun in the meantime. So let's go with a character array. No, let's go with an integer array. Don't confuse them, Chuck. All right, so int. Yep, there we are. Int array. My int array equals let's say new int, and let's set it. Let's give it 3 spots, 4 spots, 4 spots. Yeah, and there we go. Now, here's the thing. We now have a string of ints. Yeah, we now have a string of ints because I said, hey, let's give it 4 spaces. That'd be like this: 1, 2, 3, 4. Hell, yeah, that's probably why I didn't go with it. Array of characters. Okay, now we can put values in there. I didn't put values in there up here, but we can do it down here. So let's go my int array. And when working with arrays, you can go position. Now I put 0 in here because you have the address plus an offset. So let's say 15. Okay, 35. That'll work. And then in the next one, my int array and 1. 1. Keep it straight. 1 equals 12. There we are. That's good. And we got one more. My int array plus 2. Alright. Equals 9. Yeah, we'll just put 9 in there. Now, there's 4 elements, right? 4 elements. And the way to think of this is my int array plus 0. So that's right here, element 1. My int array plus 1. That's element 2. My int array plus 2, which is element 3. And so on and so forth. And what we're going to do is, let's just add them all up. So my int array plus 3, which is the 4th one, equals my int array 0 plus, and you know what? I'm just going to do this. I'm going to cheat. Control C, Control V, Control V. Control V, and 1, 0, plus 1, plus 2, and there we go. And let's just print out that sum. My int array plus 3. There we go. All right. So there we go. Boom. And 56. 35 plus 12 plus 9. Bam. There it is. Awesome. Oh, timing. What time is it? Ah, jeez. Okay, so arrays. It can be of characters, well, any of those primitive types that I listed earlier. Now, there can be arrays of arrays and such like that, so you can have an array of string. And now, references to primitives. Yes. Okay. One of the things that I want you to notice here. Primitives, notice how they're all lowercase for their types, and you list the type first, and then the name you want to give it, and then you start doing stuff with it. And reference types tend to start with a capital letter. So yeah, because they're meant to be used by other things. Now, these types, there's single capital letter, meaning that they're really basic. Watch out. And raw. It forgot what its type was. Don't try to mess with it. Okay, and so we go. So we have int. Oh, right, int. My int reference equals new int, and we can initialize it right now. Let's go 35. All right, and I'm totally miscalling this. Wait. Oh, I saw some. Yeah. I wonder, is it that? Car. Maybe car. Cannot find symbol. Alt enter shows hints. Sure. What's a hint? Huh. Yeah. No. Okay. So I just don't have the right package in. Let's go. Like that. What package was that in? I know, because it was totally saying where it was over here. This is one of the things I've worked with programming before, and so this is. Wait, did I? I see. Float. Constructors, methods, string, right, string, double. See, here's, let's try the class float. I betcha, because I know there's a capital Boolean too. I'm probably not. Let's try Boolean. Boolean capitalized. My bool. New Boolean. True. And yeah, that one works. Creating a new Boolean is inefficient. Yes, I know it's inefficient, but that's just getting them into the whole thing. References, you create a new reference, boom. Although you can just say true. Because when you go, system dot out dot print line my bool is and then plus my bool. And play that beautiful bean. My bool is true. So yeah, my bool is actually pointing to a class Boolean which holds true. And I wonder, string constructor invocation, nice. Alright, so there we go. That is a reference to a data type. And I think I'm done. I gave you, I just introduced some reference types to you. Congratulations. Now, having said that, object, alright, I will say this, object. It's not important now. It will be important later. But this and this, when I declared a new class string, it's an instance, new instance of class string, this becomes an object right there. This is an object. It's instantiating the Boolean class. My string is instantiating the string class. And we can just use it like that. So, I have clarified object. Object is the superclass of all classes, and it's not that important right now. Alright, so, I'm Charles Anderson, indie game developer. I hope you enjoyed this little bit of fun that we got to play with on the compiler. I'm on Twitter, got my own email, and y'all have a great day. Alright? I should just nope, that's not. Here's the button. Y'all have